Okay, so in the last video we talked about those trig ratios of sine, cosine, and tangent. And we set them up as ratios as fractions, but we didn't actually do anything with them and see the value of them. Well, first, just as a review, here's our right triangle. And the ratio of either sine, cosine, or tangent is given with respect to an angle, one of the acute angles, the ratio between the two given sides. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So the value of the trig ratio really depends only on the measure of the acute angle and not the length of the side, because anytime we reduce a ratio, we're going to get that scale factor, that common value, right? So let's say we had a 3, 4, 5 triangle. If we did 6, 8, 10, we would get those same ratios by reducing. So given an angle in a right triangle, we could always find the ratio. And we can do this on the calculator. So let's say this angle here is 39. Even if I don't know any of the sides of the triangle, I could still find the ratio of cosine with respect to 39. And this is where the calculator comes in handy. So the cosine of 39, if we bring up our calculator, I'm going to bring up my graphing calculator here. I want to make sure that my mode is in degree, which I see it is. I could just hit cosine 39, enter. And it gives me that ratio as a decimal. And we always like to round to 4 decimal places to be as accurate as possible. So the cosine of 39 is equal to, actually approximately equal to, 7771. And even if you don't have a graphing calculator, any scientific calculator will allow you to do these trig ratios. And we also have trig tables in our textbook that we can look at. So let's try doing the sine of 12. Okay, so the sine of 12, we just type it in, and we get 0.2079. So we could write the sine of 12 equals 0.2079. Now, how about you try this one? The tangent of 79. Okay, remember these are acute angles we're talking about. So go to your calculator and input the tangent of 79. Hopefully you get what I get, which is 5.1446. Okay? So, now what is the point of this? Well, knowing if we have our triangle here, and if we know one of the angles and only one of the sides, then we could actually find our missing side because we know the ratio. So let's look at an example. If I give you a right triangle, here's my right triangle, here's my right angle, and I'm telling you that this angle here is 42 degrees, and I know that the hypotenuse is 7. Here's my length of my missing side length. I could actually find that. Before we couldn't do that because it's not a special triangle, and I don't have two sides, so we can't use the Pythagorean theorem. And this is where trig is going to come in handy for us, okay? So if I look at my given angle, let's identify the sides that we have. We definitely know we have the hypotenuse, right? Because that's across from the right angle. This side over here is our opposite to angle degree 42, which would make this side our adjacent side. So we have the hypotenuse, and we want to find the adjacent. So which one of our ratios? And let's remember, so, TOA. If we have hypotenuse and we want to find the adjacent, which ratio are we going to use? That's right, cosine. Okay, so we're going to do the cosine of the angle. It's always with respect to the angle. Equals adjacent, which is x, over hypotenuse of 7. Now I want to solve for x. If we know x over 7 is the ratio, and the cosine of 42 is actually the ratio as well. So I'm just going to set those two ratios equal, make it look like a proportion. I cross multiply my proportion, I get 7 times the cosine of 42 equals x. And that's what we're going to type in our calculator, okay? So we're going to come back to our calculator, and we're going to do 7 times the cosine of 42. And what do we get? About 5.2. And if, let's say we're talking feet here or something. So x is approximately 5.2 feet, or units, whatever that is, okay? See how that works? Let's do another example, all right? So we're going to bring up our right triangle, make it look upside down right triangle this time. So my given angle here, I'm going to give you 61 degrees. That's 61. Here we'll give you this is 22 and this is my x. Now, with respect to angle 61 degrees, what do we have? We have the opposite side. Here's my hypotenuse. And then we have the adjacent side. Or that's the side we're looking for. So remember, TOA. Right? All right, so we have the opposite. We're looking for the adjacent. That's going to be our tangent. So we're going to do the tangent of 61 equals 22 over x. I'm going to set this up like a proportion, especially since x is in the denominator. So we're going to cross multiply here. We get x times the tangent of 61 equals 22. To get x by itself, we divide by the tangent of 61. Okay, those cancel out. So x approximately equals, let's go back to our calculator. We're going to type in 22 divided by the tangent of 61. Enter. About 12.2 units. 12.2 units. Okay, and there's our example of how to apply our trig ratios.